converting to English language, like
Oh,
converting your if then
convert
else
to English.
code
Yeah,
to
yeah.
English language, right?
Yeah, sure. So Ethereum's working on a cool technology that they call NatSpec, where the idea is, so they're building this new language, Solidity, that runs on their virtual machine, and this is like the de facto language for Ethereum, and it's beautiful. It's actually really nice. But they're trying to add this component to it that will provide sort of formal guarantees in English about what the contract will do. In a sense that like the code and the documentation kind of become one and allow the user to inspect what the contract's going to do and easily, you know, accept or deny certain actions or whatever. So I think there'll probably be a lot more research and work on that. It's a really hard problem. You're going up against like essentially the Turing completeness and the halting problem, and it gets tricky. There are probably a bunch of simplifications you can make for different contracts that will make it possible. But yeah, I suspect we'll see a lot more research in that direction. I mean, like in a year or two, the PhDs and master's students are going to be exploding all over this stuff, and that's when it's going to get really awesome. When we just have this hugely diverse focus of lots of young minds just going in all different directions on these technologies. That's what I'm really excited for, and you know, hopefully we can help provide them the tools to make it easy to play with the stuff, right? So yeah. Okay. So yeah, one of the cool things we did with Thelonious was move the consensus rules into the virtual machine, which sort of gives you this perspective that even the protocol itself is kind of a smart contract, and that basically all the code that's executing is a smart contract that can run inside this defined virtual machine. And I mean, it's more of like an implementation detail. You can still consider the base source code to be a smart contract, even though it's not, you know, technically one inside the VM on the blockchain. But this was a sort of neat, partially traumatizing experience to see sort of how versatile this virtual machine really was. And there's still a lot of work to do. And this would probably be a lot easier now using Solidity rather than LLL. But I think we're gonna move away from this very hairy problem and work on some other things for a bit, and maybe get back to this a few months down the line. Where, so I mean, essentially the idea is, did I have something on this slide? Yeah. The idea is we don't want to be in a situation where we have to download new code for every new blockchain, right? I mean, imagine you had to download a new browser every time you want to go to a different website, right? It's crazy, and we will have many blockchains in the future. This will be like an internet of change. There's kind of there's no way around that. Whether or not they're all pegged to Bitcoin, I don't know. I think that's probably not a bad idea because scarcity is valuable. But one way or another, we want a single piece of software that's able to read and produce proofs and verify proofs for the many different kinds of chains. And ultimately, that probably means it'll end up getting written in JavaScript. JavaScript's not really my forte, so I'm putting this off for a little bit. But it's something I'd like to see sort of by the end of the year, and I think could help this space around a lot, because there's so many different chains, so many different projects, and none of them are really starting to work together. Well, a few of them actually are. I mean, there's this SuperNet thing. How many of you guys know about the SuperNet? No? No one? Cool. Yeah, I just started reading about it the other day. It's very NXT focused, but my understanding is they have a client that is able to interoperate across maybe half a dozen chains right now, including NXT and a bunch of other very small, relatively unpopular ones. And that's kind of neat. And I think a lot of the infrastructure Ethereum's trying to build is going to allow for that kind of thing. I mean, they're building this like multi-protocol networking layer that should allow multiple chains to sort of multiplex over the same set of peers, and using the Ethereum VM, if it gets fast enough, it's not fast enough yet, and sort of friendly enough to developers, then we could write all the scripts we need to be able to verify different other kinds of blockchains, right? So, I mean, right now, it's probably good enough to keep up with Bitcoin, right? You could write a peg from Ethereum to Bitcoin and have all the logic in an Ethereum contract that tracks the main Bitcoin chain. And conceivably, you could do some, I mean, I always assume Ethereum is proof of stake because eventually it will be, and this mining thing is just, an intermediate step hump that we'll have to get over. But you could do a thing where you have some like multi-sig based peg on Bitcoin, so that any money that comes in is now locked and considered to be on this side Ethereum chain. And then, the Bitcoin logic isn't going to be complex enough to be able to track the Ethereum chain, but the Ethereum logic can definitely track the Bitcoin chain. And you can have the people guaranteeing the peg put security deposits up in an Ethereum contract so that if they like inflate the supply by taking money out of the peg when they weren't supposed to, you can have them slashed on the Ethereum side. So there's all kinds of cool things you can do with an Ethereum chain, even using Bitcoin, if you're willing to support, small amounts of trust in certain places to get it done, simply because Bitcoin doesn't have the scripting power yet. But with the drive from Blockstream to give it that so that it can do the whole sidechains things, who knows, maybe it will soon, and then that'll be so much better for the Ethereum landscape. But that's sort of a wait and see game, and Blockstream might end up breaking Bitcoin, who knows, right? These are like hard issues, and they would need to make some big changes to how the virtual machine works. Anyways, this is a really nice quote from Vlad that I like to repeat because it sort of keeps me focused on this browser versus website thing, right? Yeah, do you want to say something? No? Okay. So, to close, sort of like I said before, we can think of all parts of these things as smart contracts, and the ecosystem that we're building is kind of like smart contracts layered on top of each other. And again, my definition of smart contract is basically some crypto-economically verifiable execution of code. And like I said, Facebook is very close to that. It doesn't have the crypto element, but you can move to Menlo Park and get a job and audit the code base. And so you've got this awesome chain of verifiable code, but then all the way at the bottom there's humans, and the humans are never going to be afraid to troll you and try and break your thing. So just having pure crypto-economic models isn't going to be enough. We have to actually take into account how mankind fits into this and how to keep these things robust in the context of like the real world, where we have legal systems and we have government and fiat currencies and all kinds of other external incentives that feed into this thing. And that's that. Cool.
How many people are there in the project?
At Eris?
Yeah.
We have 5 core guys, and then we've got 2 contractors working for us, and we've been hiring community managers a little bit.
And how long have you been going?
We launched at the end of December, but we started working sort of around early September as Eris Industries. Before that, it was just like people working on the open source Project Douglas software. Yeah.
Incredible amount of work that you've done in such a short amount of time.
Yeah, thanks. I mean, honestly, a lot of it is thanks to the Ethereum team too. They've been doing fantastic work, and we've bootstrapped a big part of what we've done on them and on what IPFS has done, right? So we're just trying to take the best of the tools that are out there and figure out how to piece them together so that new developers can come in and not have to go through all the strife of learning how each different piece works.
And is the team actively supporting your project?
Depends who you talk to in Ethereum. Some of them do. Some of them, I think we're traitors. I'm not really sure why. But, I mean, I think Eris is good for Ethereum. I've heard many people tell me Eris tools are the easiest way to get started with Ethereum, and that's, how we started. So, I mean, I hope Ethereum is immensely successful, because we're going to need it to secure our chains if our chains are going to be considered secure, right? So, yeah, I think there will be plenty of opportunity for synergy, but in the meantime, we haven't even seen the Genesis block, right? So we kind of take that for granted.
So you said you're using a fork of the Go Ethereum?
Yeah.
So when they do an update, you do an update straight away?
No. So that is a nightmare, and basically, we've learned a very hard lesson about, it's not a good idea to try and build a business on pre-alpha software. So that code base has been changing way too fast for us to keep up with it. So around November, we decided we're just going to let go, and we will do sort of a rebase from scratch when we feel that code base has slowed down enough. And what I'm trying to do is sort of modularize the pieces that are like the controlling elements of a Thelonious chain that gives it like the individual's permissions and so on, so that they're more plug and playable, so that when Tendermint's a little more ready, I can just plug them into a Tendermint chain as well. And who knows, we might even just drop Ethereum and go for Tendermint altogether. I mean, we're porting the Ethereum EVM to the Tendermint chain. It runs already. I got a contract working the other day. And I think proof of stake makes a lot more sense for our business model and for organizations who might want to use these chains And it's another type of consensus algorithm that we can start exploring and playing with. So, yeah, I mean,
What is your business model?
it's a good question. I think we're still sort of figuring that out. I think a big part of it will be providing services and consulting in and around this space to businesses that want to onboard or maybe start with a private chain before moving to Ethereum eventually, if and when they're ready. Also, we will be building consensus systems for businesses that are looking for distributed database solutions that are somewhat self-organizing but using these new models. And for the same reason, I mean, the Go Ethereum virtual machine is just not performant enough to be sort of enterprise ready yet, and that's not really its target. So with the Tendermint virtual machine, we've made some optimizations. It's still not the fastest thing in the world, but it's a bit faster, and we hope to get it continuously faster over time. There are some weird design decisions in the Ethereum VM that are sort of geared towards like more computational purity and like theoretical beauty in a sense that lead to slowing it down a bunch. So we're looking at what it takes to get rid of those, and there'll be a bunch of compiler modifications, and we don't have to dive into that yet. Yeah.
Are you consulting with any companies yet?
Not yet. No. Well, huh?
Would you like to?
Yeah, absolutely. Get in
Got my
touch.
card?
Cool. Great. Yeah.
So you talked about junk.
Junk.
Can you give me a
Not that old talk, right?
No. Junk is the currency or token
Uh-huh.
that you use for transactions.
Uh-huh.
So do you even need junk?
No, it's junk.
Okay, and then how do you decide what happens per block? Is there some sort of a config file? I mean, you start your own blockchain.
Yeah.
You just
So here,
put
why
that-
don't I just show you? So basically, yeah, I do everything from EPM these days, which is this tool for managing chains. And maybe I can show you something a little bit.
Turn off.
Cool. So yeah, it's sort of like a kind of Git-like interface where you have like a currently active chain that you're working on. And so what you can do is say I want to make a new Thelonious chain. I'll go EPM new, and then it'll give me this Genesis file. And basically this is where I can set all the configuration options. So this is like the default one that just comes packaged with the thing that's totally boring and doesn't do anything. Basically lets everyone mine, whatever. A more interesting one looks like this. Let's see here. Cool. So this is the one. This is similar to the one we use for Together, where basically, so we have a GenDug. Did I even mention GenDug? No. So GenDug is basically the contract that coordinates all the rules of the blockchain. So he's built into the Genesis block, and during the setup, you send a bunch of transactions to it to determine, who's going to be allowed to mine and set all the rules and so on, and give it a bunch of addresses that you'll see later below. So of course, everything right now is written in LLL, but we're moving from that. These guys are like the three big public parameters that tells you whether or not everyone's allowed to mine, create, or transact. In this case, everyone can create contracts and transact, but no one's allowed to mine, except for the people mentioned explicitly down here. So, Mr. Miner McGee and this asshole is allowed to mine. But, I try, and of course me. Yeah. So sorry. So this Doug permit, this is a list of basically the permissions that this user gets.
Is the stake value for Tendermint or is it for Ethereum?
The stake value is just for looking pretty. It doesn't do anything right now. It gets written in there so you can use it. So the thing is, there's a list here of a set of contracts that you can also deploy at Genesis that can be used in the consensus protocol. So right now, I'm just using the standard suite, so it's all like the defaults. But basically, whenever a new block comes in, it's going to go ask the GenDug, hey, is there a contract that I should use to validate this block? And if so, GenDug will say, yeah, here's the contract address. And then it'll go check that address, it'll pass in the block, and then it'll run all the validation code inside the virtual machine, and return either a 1 or a 0. So you can write that code to be whatever you want, and we can show you what that code looks like.
Before you go, one more thing.
Sure.
There's no junk, no junk notifications here. How much per block of junk gets actually?
No, because we just don't care. I mean, this guy starts with a whole bunch of junk. This guy starts with a whole bunch more, but let's get rid of him. He's not nice. But it doesn't matter. Yeah. The idea is to move all the logic into the virtual machine so that we don't even care about the balances and sending amounts and transactions. Yeah, we've been really pushing to focus on like tools for dApp building and actually working in this environment. 'Cause, I mean, there's so many parts to these protocols and to building stuff on them that it's impossible to do all of them at once. I mean, Ethereum is trying to do all of them at once, but they're having a hard time, right?
So junk is the ether. What about the gas piece? Do you have any concept here?
0. Yeah. You can change that if you want, but I mean, it's nice because you can get started right away. I mean, when you launch an Ethereum chain, you have to mine for a while before you can do anything. With Lonius chain, it's just good to go. With Ethereum, you can just change a couple parameters, and that's basically what happens with like a default Thelonious chain. It's just Ethereum, with a few parameters set to 0 or whatever. But then you can do all this other weird stuff with the agenda again, with putting contracts in, and yeah.
Well, if you don't have gas, how do you ensure that your contracts don't run forever?
You see this guy? That's how. So we limit the amount of gas you can use in a single transaction.
Right.
And we can adjust that, and we're still counting gas steps so that we can check against this. But we just don't care enough to upfront limit it. And we're going to be adding, do I have this in here? No. Basically, we're going to add proof of work on every transaction as like an anti-spam mechanism, and use proof of work for what it was meant for, which is basically anti-spam. And we'll see how the network operates in the real world. Yeah. Yeah.
So you mentioned being frustrated with Ethereum not being able to handle larger contracts. Like, when do you start hitting the point where things break down, and how do they break down for you?
So yeah, you can get there pretty quickly. I mean, with like many sort of non-trivial so we deploy suites of contracts at a time, right? So it's not, and I can show you. So part of what EPM does is gives you a little tool for specifying like a deployment. That's where the whole package management thing came from. It's like deploy this contract and make the following transactions and set this value and so on. And when you're deploying big suites of contracts, it's really easy to hit the gas limit, which is the max amount of gas you can use in a block. And we were just hitting it all the time, and it just got to be too annoying, so that we got rid of it and just set a max gas per transaction, but effectively none at a block level. So yeah, that was a big one. There are a few opcodes that we added in that were nice to have, so that you can like track the address of a contract as you're going through many calls. So if you have a contract that calls a contract that calls a contract that calls a contract, and you want to be able to refer to an address of a contract in the middle, there's no like standardized way to do that. You have to pass that data down the calls, right? So we added things like that. We added like the opcodes for the encoding and decoding, so that we could do more inside the virtual machine with like object-like structures, little things like this. Questions? Should I deploy some stuff? What was I going to do? Oh yeah, this is So this is what block verification looks like in LLL. It's kind of a nightmare because it's super low level, and you have to like track everything and keep track of all these crazy numbers in your head, and copy everything into memory and so on. So it's pretty rough. It works though, and yeah, finally at the very end, wow, Jesus, yeah, the block is valid, right? So we're hoping that using Solidity, this process will be a lot simpler and a lot cleaner and a lot nicer, and we're looking forward to doing that. There's still it would be really nice if the VM could play better with Ethereum's native encoding scheme, the RLP, but that's like a hard computer science problem to implement basically object-oriented structures, and Solidity is the developer for Solidity is doing that kind of thing now, so that would probably make this a lot easier. But in the meantime, I implemented like a naive RLP encode an RLP decode opcode, so I could actually get at all this validation from within the VM and do all the serialization and deserialization I would need to.
Could you go through it a little bit more?
Yeah, sure. So, is everyone familiar with how the Ethereum virtual machine works, like the different parts of it? Should I lay that out? Okay, so let's start with Bitcoin. So Bitcoin is a dead simple stack machine that's Forth-like, where basically you have a stack of data and you can do operations that will take stuff off the stack and put something back on, right? And so every different operation will take a different number of arguments off the stack and put or not put the result back on, right? So for example, the addition operation, which I'm not even sure Bitcoin has, will take 2 elements off the stack and put 1 back on top, right? And that's it. And a base Bitcoin transaction script is just a matter of like, here, standard transaction. Cool, perfect, right. So Bitcoin, in a sense, it kind of has this contract and scripting based system where whenever you send a transaction, really what you're doing is defining the rules under which those outputs can be spent, right? So the sort of standard is this one, the pay to pub key hash, where here's your script. It's just a few opcodes that are manipulating the stack, and then when you actually go to try and spend from it, you pass it 2 arguments. You pass it a signature and a public key. And so what the script will do, it starts here. So what you've done when you pass the sig and the pub key, you put the sig on the stack, the signature, and then you put the pub key on the stack on top of it. And so what it'll do first is it'll duplicate the thing on the top. So now we have sig, pub key, pub key. It'll take the hash 160 of the thing on the top, which is the pub key. It'll compare that with the hash that was given in the transaction. It'll verify that they're equal. If not, the processing stops. And once it's verified they're equal, it's popped them off the stack. So now what's left on the stack is the original pub key and the signature, right? Because remember the pub key was duplicated. And then we run op check sig, which takes the public key and the signature, which are still on the stack, and then leaves, a 1 or a 0 back on the stack, which determines whether or not it's valid, right? So that's a very dead simple scripting language, stack-based scripting language. What Ethereum does is it takes the same thing, but it also gives you a byte array to use as memory, so that you can store. It's almost like having a second stack where you can store stuff and reference it later, sort of by variable names, and it gives you a dedicated storage for each contract, where you can store stuff sort of in a key value store and refer to it later. And then of course it lets your contracts call other contracts and do crazy stuff like that, which Bitcoin doesn't. So, so an LLL contract is pretty low level and gives you a lot of access to like all the low level constructs there. Basically our LLL contracts usually start off just with a bunch of compiler definitions. So what this is just for my convenience later, so that I can use memtop to refer to the top of the memory, so I can keep track of how much memory I've used and where to put the next thing in memory. And what I'm going to do is store that value at location 0 in memory.